Hello, welcome to another session of the Houdini Training. My name is Gianvito Serra, and today we're going to be learning about how to set up our column asset pipeline to actually export collision meshes as well. The last few sessions we have been learning, building little by little this asset to actually be able to generate, meshes for exporting in addition to materials. And today we're going to look into a bit about collision meshes. Okay. All right. So to do so, okay. Now, for those of you who are maybe familiar with how the import pipeline works in Unreal, by default, Unreal, when you import an asset, if you import any mesh in Unreal, you will notice that by default this flag will actually be on. Okay, so when a mesh is imported, Unreal will very kindly generate a collision mesh for us. Okay, which is cool. And there is going to be cases though where this is not going to be sufficient and you want to be able to create your own custom mesh for Unreal. This is something that Unreal also supports. Unreal also has some tools internal where you can actually use to create a more accurate collision mesh, like for example the convex composition. We will actually break your hole into multiple different little convex holes, which will actually wrap into the mesh a little bit better. Okay, this works in some cases, but sometimes it doesn't work so well. Okay, so I like to demonstrate is how we can actually build a procedural pipeline which will procedurally generate convex meshes for collision that will support as our assets continue to change. Okay, so I'm going to these finishes here. You can see the result. To demonstrate so, I'm going to actually create an asset that is very typically, requires some kind of convex hole decomposition. Obviously this column is very simple. Just a cylinder collision will generally suffice to actually take care of the column. But perhaps in another particular case we'll go with something a little bit more interesting. And this is probably going to take a long time. So we're going to go ahead and actually just let this process on the background and we'll just go ahead and actually start working here. Okay. The reason why we want to actually learn a little bit about how to actually make our own meshes. Okay. So we'll take off from the project that we left last time where we created the vertex colors and the two UVs. And the first thing I'm going to do is I'm going to convert my column asset generator into an Archway, column Archway generator. Okay. Let's go ahead and allow editing of contents and dive inside. I'm going to dive inside of our column geo. Okay. Which creates our UVs and everything. Let's actually start creating an Archway for this. Okay. So the first thing that you think about when you're creating an archway is that you want probably is start with a circle. Okay. A nice thing about starting with a circle primitive is that it will be pretty straightforward. It's a straightforward way to actually create an archway. Okay, because an archway is obviously just of a circle basically. Okay. So let's switch our circle from being primitive to polygons. Okay, so we have our little polygon points there. For the sake of clarity, I'm going to go ahead and turn off the environment light for now so that we can see a little bit clearly what we're doing here. Okay. And the next thing I want to do, I'm going to go ahead and template the archway, is to actually make this circle fit a little bit better with these proportions that we have of our whole column. Okay. So next thing we're going to do is we're going to do a transform. Okay. And the first thing we want to do is that we want to actually transform this to the top of a column. So, from some of our previous classes, if you remember, the VBots expression is an expression that we can use to get bounding bots information of any surface operator node in this scene. So we can say bbots, and then go up one level, and then get our column generator node, okay? And say that I want to get it d_y mats, okay, which is going to give me the maximum y position of the column generator, okay? Good, that puts a circle on the top, okay? Next, we want to be able to actually have the scale of this circle to actually match the proportions of this, okay? So if we go to uniform scale, we can make it a ratio of the actual height. So we can copy this parameter and paste this expression here. So we have the y mats here. Now, remember we were dealing with radiuses here. Okay, so we want to be very careful with the size that we pick. So instead of actually going with the full size of the circle, we probably want to go with maybe just a third of it. Okay, so just to actually get a bit more of like a golden ratio type of feel. And then also, we want to potentially move our circle so that the center arch is on the left, okay? So let's go ahead and actually copy this parameter. Actually, very simply, we can just do this on the circle by simply saying that we want our center to be not at the origin, but on the left. There we go. All that is doing, if we go back to the original circle, is that it is basically setting the circle center to not be on the center, but to simply be at the left, okay? Because our circle radius is 1. By setting the center to 1, that just puts the leftmost part of the circle at the actual origin, okay? Let me hide this so we can see this a little better. So when we transform it, based on the expressions that we have right now, our circle is pretty much where we want it to be, okay? Very cool. Maybe give it a few more divisions. Maybe we'll go to 24. Okay. Next, we are going to use a brand new operator from Houdini 15, which is very useful, called polyexpand2d. Okay, polyexpand2d allows you to grab any curve or any shape and do what is called a straight skeleton expansion on it, so that we can actually get out of our circles two circles which start from the original circle, and actually go outwards to actually meet the criteria of a straight skeleton, okay? So we can pick an offset that kind of matches the size of this, but it's better if we actually use an expression for this as well. Again, just like we did with the actual transform, we can use the bbots expression again. So we can say bbots, and then pick up the column generator again. I can obviously copy and paste my expressions, but I like to actually type them just to go over this again, okay? So it's bbots, and then in quotes, the path to the actual column generator node. So // column generator tutorial 1, okay? And then I want to pick up this tiny d_edge size, which gives me the size of the actual column on the edge, okay? Then what I want to do is that I want only half of that size, because I'm expanding from the center of the column out to waist, okay? So that gives me the exact location there, okay? Cool thing is that if I actually change the height, or if I change the radius of my column, these circles will always match, okay? Remember, that's the beauty of Houdini, that everything can be set up in such a way that is fully persistent and non-destructive, okay? Awesome. Just so that people can see this a little bit more clear, I'm going to put my expression here in a little sticky note. Oops. And put the expression here, okay? So we can see that a little bit more clearly. Okay. Just to remember, on the bbots expression, there is a constant here that you can use to get the size of the actual min mats. So for example, in the transform node, the expression that we used to get the y mats was instead this one. Okay, and you can see the difference: edge size, y mats. We also have y min, for example, or z min, etc., etc. Okay, cool. So now that we have that, the first thing that you'll notice is that we actually have two circles when we only really want the archway shape. Okay, so let's go ahead and actually do that, fix that, and just put a hole operator. The hole operator will go ahead and carve a hole for us in between the two primitives. Okay. And the next thing we want to do is to actually clip the pieces of this of the arch that we don't need. Okay, so let's go ahead and actually clip the bottom by using a clip operator and setting the origin to the centroid of the y-axis. Okay, so the expression that we're looking here is called centroid, which returns the center of an object. In this case, I'm going to use 0 because I want the incoming node, so whatever is coming out of hole 1 is going to be 0. This is the same as if I was doing hole 1, but because you can also use 0 instead, which will denotate the first input into this node. If this node had 3 inputs, you can use 0, 1, and 2 to actually return the nodes that are inputs to this node. Okay, another useful part of Houdini 15. Now we want to get d underscore y, which in the case of centroid returns the actual centroid in the y-axis. Okay, so now when you see here, the clip sub is at the clip node is actually just clipping right on the actual y-axis. Cool. Now, since this is going to be symmetrical, I mean, eventually we're going to just actually mirror our archway over to the other side. Okay, so that we don't have to actually maintain both sides, and also to ensure that both sides are actually perfectly symmetrical, you know, because this thing came with a circle, we're not necessarily guaranteed that all the little points are actually going to land exactly where they land for every division. Okay, so to do so, just going to add another clip. No. And that will simply give us another separation. That's, and then similar how we did the y expression here, let's copy this one, paste this one here, but set this to the x-axis. Okay. Now you notice that the clip is cutting on the wrong side. All that we have to do is to just switch this from primitives below the plane, and that will actually now pick up the proper side. Okay. Next, I want to translate and manage to this back into the actual to give it a little volume. Okay, so let's do an extrude operation. Actually, we'll do the new poly extrude for this, an improved version of the original extrude from Houdini 15. And for the distance, we're going to copy the same expression that we had on the poly expand. So I'm going to copy parameter here, and then paste the expression on the distance. But I'm going to change a few things. Instead, we're going to go based on the z size, because we want to go on the depth. Okay, which gives us this. But what I want to do is actually I want to go the full size and then actually translate it over to cover the whole piece. Okay, also want to make sure that we output the back. Okay, so just to show again, the distance options allows me to change the distance of the extrusion, just to actually make it a little clear. Let me do this again. Okay, I'm going to cut this out, put one here just to show how the extrude works. If I change the distance here, you will notice that increases the extrude distance. So in this case, I want to actually drive this with my expression. Okay. And then what I want to do is, there is toggles here where you can turn on and off whether you want the side faces, whether you want the back faces, whether you want the front faces of your extrusion. I want to actually have my faces because I want my extrusion to have a full volume. Okay. That I have that, I'm going to go ahead and transform my extrusion forward to about half of that head size expression. Okay, so we're going to copy this expression, paste it on the C. Okay, so now it's translating here, but this time I want to only go halfway. Okay, So now we have the archway sitting perfectly on top of the column. Awesome. Very cool. Now if we want to, we can actually give a little bit of just a little bit of actual little bit of a minimal scale just to make it a little bit shorter here. Now all we have to do is to just put a little bit of a scale here. So we'll do maybe 0.8. Now you will notice that it's only scaling from one side right now, okay? Because of the hoverboard transformations work. But if we actually go ahead and add a pivot to this, and we set our pivot to the center of C, so Z is Z, now this is flush from the center, okay? All I'm doing is I'm telling, okay, do your operation based on the centroid of the actual geometry, not based on an actual pivot of 0, okay, which is what's causing the problem since of the order of transformations that we have here, okay? Likewise, when we go to the polyexpand 2D, after we do the offset, we can also add to this expression just a little bit of a threshold. So we can multiply this by 0.8, and that should make the archway just a little bit thinner, okay? Very cool. The reason why is because it's taking the width of a column, but then it's multiplying it by 0.8, so just getting a little bit of a fraction of it, okay? Very cool. Alright, so now we're pretty much almost there. Go ahead and assign it to material as well, so that it follows with everything else that we're doing. We'll also do a quick UV unwrap, so this mesh has UVs as well. Okay, but for the material, we'll just go ahead and actually assign it to the gold right now, just to keep things simple for the time being. Okay, and let's go ahead and actually merge it with the column. Okay, now that we're merging the two, we can probably turn off our template that we started with up here. Let me make this a little bigger. Turn off the template. Okay, we can see things a little bit better now. Alright. We can now also, if we want, come back to the top level, go to the environment light, and re-enable the light in the viewport. Okay, so now we can see things a little bit better. Okay, so it's a very, very, very quick and cheap and dirty archway that I put together here. Okay, very cool. Now we can obviously make this a lot more sophisticated and pretty, you know, adding some bevels, making some nice little patterns and everything, but because the purpose of this tutorial is to look into collisions, we're not gonna do that. We're just gonna keep things a bit simple. Okay, so going back into our geometry, okay, next thing we want to do is that we want to actually mirror this. Okay, so first we want to go ahead and actually transform it so that we move the area that we want to mirror to the actual origin. Okay, so let's move. We want to basically move the rightmost side over to the right. You can do so very easy, very simply by just setting the translate x to a variable of that particular location. So just do x maths. Okay. And then what we want to do is we want to go the inverse of that. Okay. So basically taking the maximum position on the x, and then actually going the opposite direction of that to put then that position at the origin. Okay. Very cool. I'm going to use also a clip operation. This is just to delete the little face on the front here. Set this to 1 direction. So the cuts on my cutting plane is on this axis, and then switch to primitives below the plane. Okay. Because the face is flush against the actual origin, immediately gets clipped by the actual clip sub just because it's there. Okay. Next we're gonna do a mirror operation, which is gonna mirror our archway over, and here is our archway. Okay, very cool. And we'll go ahead and actually put an output node here. Now, this is now our archway generator. Okay? Awesome. Now, as you can imagine, creating a collision mesh for this will take a little bit of sophistication, because we need to make sure that the collision mesh that we generate allows the person to actually be able to walk to the arch. Okay? What I'd like to show you is what happens if we just let Unreal use the automatic collision generation for this. Okay? Let me just really quick first, I'm going to rename this to out, and I'm going to set this to my color blue for cleanliness. Okay? Let's also make sure that on the column export node, we're actually still referencing the correct, we're merging this to the correct column. Okay? Very good. Also, if you remember, we made this proxy material, which is assigned to the object that is coming in. The objects are coming in, so that the gold that is here is preserved in the Unreal Engine in the diffuse color from the last tutorial. Okay? For that, we're using groups. So let's actually make sure that we have a group on our column. Okay? On our arch rather. So we're after the material assignment, we're gonna add a group sub. I'm gonna call this our archway. This archway, there we go. Okay. So now if we go back to the export node, we can go ahead and also add the archway to the things that get assigned to our proxy gold. Okay? Very cool. Awesome. Alright, so let me go ahead and save my scene. It's gonna be with Archway. Okay. And let's go ahead and export this so that we can see what actually happens in Unreal when we import this by default, and let Unreal do the auto collision generation. Okay. Set this to Archway. And let's hit export. Very cool. Okay, going back to Unreal. Notice that Unreal is still actually trying to generate a convex hull. We're gonna go ahead and actually stop it. It looks like in order to stop it, I'm going to actually have to kill the process. Okay, I'm gonna pause the video during that, and then we'll go ahead and actually try to just re-import my column. Okay. Okay. So let's start with a new level. Make sure I'm recording okay. And let's go ahead and import our new archway. So we're gonna hit import. Okay. Let's import our column archway. I'm gonna let Unreal auto-generate the collision meshes, okay? Which is this setting up here by default. I'm gonna do import all. Okay. And here is our archway. Now again, if you are actually doing this in Unreal, you may choose to actually build this as separate static mesh actors and actually then composite the piece together here. Okay. Just to show the purpose of this class we're dealing with in regards to collisions here, I just wanted to do it this way. Okay. But let's see what happens now if we play. Actually, let's just take a look at the archway and look at the default collision mesh that is generated by Unreal. So as you see here, this is a problem because it's keeping the collision is actually doing a convex hull over the whole archway, right? So if we go and try to play through this, what will happen is that the moment that I try to go through the column, our archways, I can't because they are too small. Okay. So we can obviously try some of the tools inside of Unreal for doing convex hull decomposition, but every time that the archway changes for any reason, then we have to keep changing the collision meshes on the fly, or every time. Now if we actually go into Houdini, because we have all this data here and all the data is persistent, we can actually set it up so that it will automatically update our collision meshes as this thing is being generated. Okay, so let's do that. Let's go back inside of our column geo and go ahead and start generating our collision meshes as well. Okay, so let's go back to our column. So here is our basic column. Okay, let's go ahead and create a collision just for this. Okay, as you can imagine, the simplest thing that we can create to wrap this column is really a tube. Okay, and we want the radius to be the same as the column generator radius. Okay, so we can even pick up just the parameters that we have here to make it really simple. Okay, let's go ahead and put the focus on this so we can see this. And let's go ahead and actually for the actual height, we'll pick it up from here. Now we'll just put it high here. And in the center, we want it to actually be the same as the height, but divided by 2. Now one thing to note though is that I'm actually not taking into account the caps into the height, which is probably not the best. But we can fix that very easily by just using instead the bbots expression. So let's just do bbots. And then we do the column generator tutorial. g_y size or y maths. Okay. Oops, not on this one. I meant to go on the height. Okay, this one I want it to be the x maths. Very cool. That's actually wrapping a lot better now. Now let's actually go ahead and copy this, which is the height, and put that into this height right here. Okay, put divided by 2 so that it sits flush. Okay, very cool. So now as this increases on height, the collision will always follow this. Okay, so make sure we have make it polygons, and that we have end caps for this. Okay, very cool. So now we have a polygonal collision mesh for this. Okay, can probably reduce our columns to 6. You know, you can choose how many polygons you want to have depending on your performance. Beautiful thing here is that now we have access to, we really can do whatever we want in regards to this. Okay, all right, cool. Now there's a few things we need to change though, because as you remember, if we go to the archway and we see the final archway, this actually has shifted over to the left. Okay, so we need to make sure that this is actually centered in such a way so that it matches the full column. Okay, so in order to do so, we need to be able to actually transform this the same way how this actually was transformed here. Okay, so let's go ahead and actually add a transform. Okay, and then for the transform expression, we can just pick up the same transformation that we have here. So we copy the parameter from here, we do paste copy relative references, and I think the reason probably why I didn't like it is because of the fact that this is actually using a variable. So instead of doing that, let's actually do bbots merge one, And let's just pick up the d underscore @mats. Okay, so then that way we just, it's in essence doing the same thing that what @mats is doing, but we're basically picking up the @mats position of this and translating based on that. Okay, now we're actually using a negative number here, which is actually giving us this. Okay, and to get the next one, we can simply copy and paste this and then just take the negative out. Okay, so now we have a left column and a right column, and I'm gonna go ahead and create groups for them. Okay, so this is gonna be my group for my left column collision, and then I'm gonna have another group for my right column collision. Okay, very cool. For our archway, what I'm going to do is that I'm going to do a convex hull. Okay, so for the columns, the cylinders are perfect. For the archway, the thing to remember is that the rule of collision meshes is that they have to be convex shapes. Okay, they cannot be concave. If we look at the documentation from Unreal, this is okay and this is not okay, and the reason why these ones are not okay is because they have holes that create concavities in the mesh, whereas these do not have any holes that create concavities. They are actually convex meshes. Okay, so this will be very simple. We could actually have just one side and then mirror the other side, but just for simplicity we can just take the mirror version and do both sides. Okay, so let's go ahead and actually from here, let's just take the archway by itself and go ahead and stop doing this here. Let's generate a convex hull for this. Okay, all I did to get the archways, remember we created an actual group here to separate out the archway, and I use a blast operator to isolate the archway only by itself. Okay, let's use a tetrahedral sub to generate a convex hull. Now the tetrahedral is just a general operator that does operations related to tetrahedral meshes. Okay, not gonna get too much into what tetrahedral meshes are in this class tutorial, but what I will tell you is that we can simply use this to also generate convex hulls very easily. So in the output, by default is set up to export tetrahedrons. Okay, but what we want is to actually generate a convex hull. Okay, and here is a convex hull of our archway. Okay, very cool. We can even, if we want, poly reduce it. If we want to optimize it a little bit, which will get rid of some of the actual extra polygons which are extraneous. Okay, so we'll do it. So we can go to something like this. It's quite minimal here. You can go probably as low as we want, but I think for an archway, this actually I think would probably work even better. I think actually I like it the way we had it before. So 49. There we go. Okay. Now we can merge. We can go ahead and actually create a group for this, and call this or archway collision. Okay. Very cool. Let's go ahead and merge these together. So now we have our full collision mesh here. And here is our full collision mesh of the actual archway. Okay, and if we click on this and template this, you can see that we now have these collision meshes set up correctly. Okay, very cool. I'm gonna go ahead and actually put a null node here, no, as in null, and let's call this out underscore collision for nice and clarity. Okay, I like to sometimes color these nodes green just to tell me that they're not necessarily the out node, but they have some kind of function that is important to this, okay? The beautiful thing about this is that we can go back to our column generator and still play with settings such as the height. We can play with the radius, and as you can see, everything simply adapts to our changes as expected, okay? That's a beautiful, and then one of the beautiful things about Houdini is that everything is fully persistent, okay? So therefore, if we wanted to do changes to the way this looks, it becomes very easy for us to actually always generate an archway that kind of matches the expected golden ratio of these archways, okay? With all of our collisions. Very cool. Now, to get this to Unreal, there is a few things that we need to do, okay? Let's go ahead and save this for now. If we look again at the documentation, the way Unreal expects these meshes to go is in one of three formats, okay? A bots format for a bounding bot, is SP format for a bounding sphere, okay? Or an UCH for convex objects, okay? For the most part, you're gonna probably just use UCH, which is the convention for convex objects, and not necessarily worry too much about this, okay? But you can use UBX if you want to. USP is used only for certain special collisions, rigid body collisions. So for most part, we're just gonna deal with UCH. What Unreal requires is that in the FBX file, your collision meshes needs to follow this naming convention, okay? They need to be preceded with UCH underscore the name of the actual mesh you're exporting underscore and then the number of the actual mesh, okay? So in our case, just to show it's a little bit more clear if I show it here, what we're going to need, okay, if we go back to our column export node, is to add a new object or a new geometry. So let's call this is gonna be a collision geo, and the way how it needs to be called, again, because this is a convex, it's gonna be a convex hull, is gonna be UCH underscore column underscore geo underscore 01. Okay. So again, if we look at our naming convention, is UCH render mesh name and a number. Okay, so UCH column geo 01. Okay. What we do is in here, instead of a file operator, we're gonna go ahead and delete it, and instead we're gonna add a object merge like we did before. Okay. Call this collision, and we're gonna go ahead and actually import that object which had the collision data. Okay, we're gonna set it to relative. Okay, we're gonna only filter this by 1. Okay, so we're gonna just pick up the archway collision. Okay, again, remember, Unreal wants 3 meshes that are convex. It doesn't want one big mesh that is concave, which is what this is. Okay, so by doing this, you're actually passing this as a single mesh. Okay, so that's cool. That creates 1. We need 2 more. Go ahead and press Ctrl C and then Ctrl V to paste and create our second one. Dive inside. For the second one, we simply pick up the left column collision. Okay, and we do the same thing, Ctrl C and Ctrl V, and then that is going to be our right column collision. Okay, very cool. So now we have all of our collisions. Okay, and we can go ahead and actually test this out. Let's go ahead and save, and let's go ahead and do another export. Okay, so we'll go back to Unreal. Let's go ahead and delete this, and then we'll do a clean reimport. And then turn off auto generate collision, okay, so it doesn't try to import the collision, create a collision mesh for this. Okay, now if we look at our archway and go to edit, you will notice that now we have the collisions that we created from Houdini. Okay, very cool. So we go back to Unreal. I wanted to just play this. We should now be able to actually go to these collisions. So we may need to actually make the archways just a little bit bigger to get through. You can see I'm kind of fitting here a little bit, but not quite. That should be very simple. We can just go back to Houdini and make our archway just a little bit bigger. Okay. And make the columns just a little bit thinner. And then go ahead and hit export again. Come back to Unreal. And then we hit import. Okay. Let's try that again. And there we go. Now we can go to our archway, no problem. The collisions with the columns still work, you know. If we wanted the original size of the columns, we can also make the radius of the actual column collisions a little bit thinner, so in a way, you know, it gives a little bit more room for us to actually get through. Okay, but the beautiful thing about this now is that at the same time that we create render meshes, our collision meshes are also updated on the fly, which is great. It makes the, you know, the creation of these assets much easier, because you don't have to keep regenerating the assets every single time, okay? Or regenerating the collision meshes every single time, okay? And again, you know, we could also, you know, split the archway into two and actually have two convex holes, one this way and one this way, to make it just if we wanted to actually have this here. But for my purposes, this actually worked just fine. Very cool. Now we're done with everything. Never forget to actually right click on this and then save your node type. And then match current definition, okay, which will save everything for us. Very cool. I'm gonna go ahead and save my scene as well. And I think that should cover this for collision meshes. Alright, well, I hope you found this tutorial useful. My name is Gianvito Serra, and we'll see you on the next tutorial.